So far we are doing sequential execution, right? So we are writing function, let's say writing a function definition, let's say this is func1. Then we are writing another function, let's say func2. We are giving a call to this, let's say func1 call, and let's say func2, right? So how it is executing Python, so it will start from top down manner. Okay, this is a function definition, it cannot execute it unless and until there is a function call. It will not execute this, it will not execute this. Now when it encounters a function call here, it will pass the control here, execute this set of statements, come back here. Next time, okay, function 2, go back here, execute this function and come back, right? So the execution will be sequential. So now what I want, if I'm writing multiple function, all this function execute in concurrent manner. That means by the time function 1 is executing this function definition, your function 2 also should start executing this function 2 at the same time. And that I can do using my threading. So when we discuss threading, the architecture will be, I will have one process. Okay. So when I create each Python file, for each Python file there will be one process. Okay. So in sequential manner, this process takes care of all these activities. Now when I create threads, I will be creating threads under this particular process. Okay. So let's say I'm creating thread 1, I'm creating thread 2, and I'm creating thread 3. Okay. So in fact, at top level, the entire execution will be controlled by a process. But under the process, I will have multiple threads, T1, T2, and T3. Okay. Now it's a job of process to control all the threads. That means it's job of process that it will make sure that all the threads are executed and completed its execution. Okay. Because ultimately each thread will be doing the execution in the background. Okay. So how you can do threading in Python? So for that, we have to import something. Import threading. Okay, it's a built-in module. You don't have to download it. So I'm writing two simple definition. Let's say this is your square. Okay, I will pass one number, and this method will give me, let's say, inside square function. Okay, and this will print me num into num. Okay, I'm writing another function. Let's say multiply. Okay, so the concept of threading will be the structure will remain the same. It's just your logic of writing your code will be different. So print. Okay. And this function will give num1 to num2. Okay. So I want to execute these two methods in a concurrent manner. So for that I need to create two threads. Okay. So T1 will be one thread, T2 will be two threads. Okay. So threading dot thread. I'm creating an object of a class thread. Okay. So this is how I will create object. Threading dot thread. Okay. Now I need to tell what this particular thread will do. Okay. So I'm saying that this thread should execute this square method. So for that I need to specify the target. Okay. So it takes a keyword arguments. So target equal to and the function name you will specify. Okay. Here I will say target is equals to multiply. Okay. Now the methods which we are writing are taking some arguments. So this is taking one argument and this is taking two arguments, right? So that thing also I need to pass here. Now this should be compulsorily and mandatorily, this should be a tuple. Okay. Even it's a one argument also, I need to pass as a tuple only. Okay, and for a single value I need to write it as something 5 and comma. Okay, here I'm writing 5 comma 6, let's say. Okay, so now I have defined two threads, but when I define two threads it will not start the execution. Still I have just defined the structure. Okay, so to start the execution we have method t1 dot start. Okay, so it's a method of your object, that is t1 is my object and I'm invoking start method. Similarly I'm saying t2 dot start. Okay, so now if I execute this, so as my program contains only one line of code, it looks like it's executing in a sequential manner also. So for that what I'm doing, I'm saying something import time, just to induce some sort of sleep. So once I print this statement, I'm saying, let's say time dot sleep for 10 seconds. Okay, so let's see the output. So now it's saying inside a square function, inside a multiply function, it printed 30 and it's waiting for 10 seconds to finish. After that it printed 25 and now it's showing finished. Okay, so this is showing inside square function and inside multiply function at the same time, which means t1 is started executing square, t2 is started executing multiply function. After printing one statement, so there is nothing to wait, so t2 finished its execution, but t1 there is asleep, so it printed one statement and it's waiting for that 10 seconds to get over. Once that 10 seconds get over, it will print its output and then you will see this finished. Now to finish the program execution is a job of your process. Okay, so your process will take care that all threads has finished the execution. So your process will make sure that that all the threads has completed the execution. So that is the reason if I execute this, it's showing inside square, inside multiply and 30 quickly. It's waiting and still you will not see that finished here, because your process is making sure all the threads has completed the execution. Now once the thread has printed the value, now it will show, okay, this is a finished now. Okay, so when you have two completely independent methods, then you can write a thread like this. Okay, let's say now you want to make sure that so let's say you have multiple threads and this t1 is the most important method and you have to complete the execution in order to start the next few methods. Okay, so if you want that your t2 should wait for this t1 to be finished,
then we can say
then we have something called t1 dot join. If I execute this inside a square function, now it is not starting this multiply function. Why? Because now it is waiting for t1 to finish. Now once t1 is finished, it will start the t2 and execute this. Okay, so it is a difference in output. Here now it's waiting for t1 to finish the execution. It will not start t2 unless and until t1 finishes the execution. Okay, all right. So let's discuss concept of daemon threads. Now I'm saying, let's say daemon equal to true. Okay, so I'm executing this code. Just tell me what is the difference in the output.
It's not executing the square function.
It is showing this inside the square function.
No, but it's finishing 0.4 seconds. But yet it's not showing the form. This a square of.
It's not printing the answer.
Yes.
Right. So we discussed if I'm writing, so it's the job of my process to make sure all threads have finished the execution, right? This is the case for your normal threads. Now, if I define a particular thread as a daemon thread, okay, now the concept is the process will not wait for this thread to complete its execution if all other non-daemon threads has completed the execution. Okay, here T1 is daemon thread, T2 is non-daemon thread. Now process will not wait for T1 and T2 both. Now process will only wait for T2 to complete its execution. Once T2 is finished, it will terminate all other threads. Okay, so that is the reason it completed the execution of T2. That means it printed this inside a multiply function, printed its value. Okay, but as T1 is a daemon, it will not wait for T1 to complete its execution, and it will terminate the T1 in between. Okay, so when we generally use daemon threads, so whenever we are writing a program using a threading architecture, we are writing a memory intensive applications. Okay, so that is the reason sometimes we generally write a threads, and the sole purpose of that thread will be just to clean up the memories. And if you see, that thread is not that much trivial to my program execution. So that is the reason I can define such threads as daemon thread, so that even if all other threads has completed the execution, I will simply terminate this thread, because ultimately it's just a consuming time now, because the important threads have already finished the execution and I don't have to execute anything more. Okay, but yes, if you're writing some critical functions, you will never define it as a, you will never execute using a daemon thread.
What if it is false over there?
Defaultly it's false.
Default.
That will be a normal execution, that both will work in parallelly. What is this? Okay, still waiting. Okay, now it will print 25 and then finished. Okay, so defaultly this is false. Now when we write a threading, the most important problem you will face is working with the global resources. Okay, so let's say I am defining a variable here. Okay, now I want this variable to be accessed by both functions, that is square also and a multiply also. Okay, now the main problem is both of these functions are executing at the same time, right? Now there is a possibility that at same time both function will modify this count value, and this can be hazardous, that I will not get a correct value to implement. Okay, so for now just forget this thing. I'm writing a for loop. So first thing, I want to access this global variable, so I'm writing global count. Okay, similarly here also I'm writing global count. Okay, all right, I am not writing this. So if I'm writing for loop for value in range of 5, okay, I'm saying print the count. Okay, then let's say time dot sleep for 2 seconds and increment the count. Okay, so I'm printing the count, sleeping for 2 seconds, and then increment the count value. So similarly, I'm copying this loop here and pasting it here. Just let's say I'm changing the sleep time to 1 second. just to make sure that these two methods will conflict with each other. Okay, so I'm printing the count. All right. So initially I'm initializing it to 100. So now if I execute this, oh my bad. I'm incrementing by 10, and here I'm incrementing it by 5. Okay, so it started with 100, 5. So in between it's incrementing by 5, sometimes incrementing by 10 directly, right? So it's like conflicting with each other. So if you check the output, so started with 100, 105, that means incremented by 5, that means multiply got the axis. Okay, then 10, that means it is incremented by your square function. Again 5, 5 again 10, this is 5, this is 15, because in the meantime count is incremented by both of them and then print statement got executed, and 65. So if this is happening, you cannot check any condition, right? So you have to prevent this, and you can prevent this using concept of locks. Okay, so the concept is, before actually modifying any global variable, that particular method needs to acquire the lock. Okay, once the lock is acquired, then only that method can modify the value. If lock is acquired by any other method, then this method will wait unless and until the lock is released. Okay, so how to define locks? So I'm creating a variable called lock. So it's again heading dot lock. So I'm creating an object of a class lock. Okay, now here I'm writing, before going to the for loop, make sure lock is acquired. Okay, acquire the lock first, then change the count value, and once this is done, then release the lock. Okay, here same thing, lock dot acquire. This is a method, and here I'm saying lock dot release. Okay, now check the execution. So now only one method will get access at a time. So now you can see 110 got the access. It has printed this inside a multiply function. Okay, but it is not executing, it is not incrementing it by 5. Why? Because initially the log got acquired by your square method. So that's why if you see the output, incremented by 10, then 10 again, 10 again, 10 again, and 10 again. Okay, now once incrementing by 10 is done, now start incrementing by 5, 5, 5, 5. Okay, it's like now at a time only one method is modifying the global resource. Okay, so this is how you can prevent the problem with the mutual exclusion. Okay, but with this lock we have few problems. So here we are making sure that I'm acquiring the lock, right? What I'll do, I'll not release it here, and let's see if my multiply method can release the lock before acquiring it. Okay, so before I tried acquiring here, releasing here, then acquiring here and releasing here, but now what I'm doing, acquiring in one method, not releasing by same method, and other method try to release it first. Okay, so even if now if this works, then it should also create the chaos, right? Because now it has already acquired the lock, but this method has access to release it and work on the variable. So if I see the output, so it's not throwing an error 5, then okay, so it's again mix up, that is incrementing it by 5 sometimes, incrementing it by 10 sometimes, right? So that means it's not mandatory that if one method is acquiring the lock, it's not mandatory that same method should release the lock. Even if other method try to release the lock first, then also it will work. Okay. So this is also one of the problem, and that you can solve using something called R lock. Okay. So what is the R lock? So R lock stands for re-entrant lock. Okay, that means now I'm putting a restriction. If one method is acquiring the lock, only this method can release the lock. Okay, this method cannot release it. Okay, if this is the case, then it will throw an error. Okay, so now it is saying cannot release that unacquired lock. So now it is considering that square method has acquired the lock. The square method will execute the function, but it will throw an error in your multiplier function. That is the reason you will not get at least the wrong output. Okay. So the standard way is you will acquire the lock first and then you will release the lock. Okay. So how we can use? So in that day we discussed this threading example. So this is one beautiful. So code. Okay, so here what I'm doing sequential access to this methods, sequential access to one card. So at a time only one card is getting fetched, right, from that magicbricks.com. So I can write a threading instead, and at a time I can use multiple methods. Okay, so let's give it a try here. Where is my inputs? And print the content. Okay, so thank God. Now this is my loop. Right. Okay. So what we are doing, we are finding out the cards, and each card which we are doing is executing some. So for this method, we are executing some method, right? Okay. So how about each card we can execute in a different method? Okay. So can we do this? So I want simultaneous execution of all these cards. Can we do? Okay, so that can be the one of the real use cases. Whenever you are working with your web applications, you will be submitting multiple GET requests to the multiple pages, and you will fetch the data simultaneously, which will speed up the execution for you. Okay, so let's give it a try. So here I'm getting this URL, so and I'm getting multiple cards here. Okay, Now to fetch one of the card, I'm making one request at a time. Okay. So what I can do, I can write a thread that at a time I will fetch multiple cards. Okay. So here I have what you can do. So here I have these cards. If I'm writing a for loop, that means I'm ultimately getting one card at a time, and I'm finding this. So if I get a get request, so can we define a function for this? So if I write everything in a function and by fetching the card, if I use the one card, then I can try it using the thread. In this example, ultimately we are getting one card at a time. So what we can do is fetching all this data, we can write it one function. Okay. So here we are taking, let's say 10 cards, right? So I can assign a method that t1.start for one thread. So one thread will take care of this 10 cards, and simultaneously I can ask a second thread to execute the same function to execute next set of cards. So at a time I can access 10 cards. Okay. So let's write it. Let's define a function. So not a good practice, but let's define it here only. So definition print data. Okay. So I will pass the card here. Okay. So if I'm getting the card, then everything I have here is Control X, Control V here. So whatever card I have, I'm passing here, and from that card fetch this data. Okay. So inside this for loop, if I give a call to this function, so let's first check sequentially is it working or not. Okay, so these are my 5 cards. I'm writing, let's say, for card and cards. So this will take care of, let's say, 10 to 15 cards. Okay, so next, so first 10 I'm taking here. Then let's take next set of this, and this is the print data. Okay, and I'll pass the card. So this is my sequential execution structure. How I can create a thread? So I will say something. Let's say t1 is equals to. So we need to import the threading first. So import threading. So here I will say t1 is equals to, what should I write?
13 dot.
Threading dot
Thread.
thread. Okay. I need to specify the
Target.
target. What will be the target? Is
Card. And data.
this print data. Okay.
ArcGIS.
And then ArcGIS. We need to define a card, right? I think this should be a tuple. So I'm just writing a card. Is there any issue? Syntax. Okay, and after that closing. Okay, and instead of writing this print data, now I will say t1 dot start. Okay. Similarly, let's create this t2 and t2 dot start. So now this is an example where there is only one method and both of the threads are executing same method in a parallel, right? Let's see, do we get any conflicts or not? I can see my output is much more faster, right? So want to check a performance? Sure. Let's try it in both methods. So I'm doing this. Here I'm writing my normal print data method and passing the card, right? Copying this here and print data function card. Okay. I need to check the performance of all these two for loops, that how much time it is taking to print this. Which library I'll use? Remember time it? Okay. Here I am saying, let's say t is the time taken. Are you using the same variable anywhere? Let's say time. So I need a function that is time it dot time it. I need to define stmt is equals to in a triple quotes. So till this point, this is my code, and triple quotes end number equals to 1. Okay, and let's just print this variable that is tm. Cards not defined. Okay. From where are we getting these cards?
Okay.
Right. Okay. What's that? So what I'm doing is, but then it will give me a problem in a response. So I need all these things to be Control X below this function. I'm writing the statements. Now let's execute. Request is not defined. I need all my inputs to now what? Wants everything in one statement. Import request. Then I'm printing my function. So in short, all my code is inside now. Time it. So now get title dot strip and the split. Where are we doing this? Did we broke anything? Let's do title. Oops. Okay. I guess better to go with normal finish thing only, because ultimately in a time it also I'm copying everything in this. Oh, now we are executing in both way. Okay. So let's check the threading time now. First, IT1.thread and start. And type object has no attribute text. So somewhere down the line we are getting this much data. Okay, so using thread it took something around 7 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and in one of them we got exception 14. Okay, so it printed 14. In one of them maybe there's some issue, data issue. It took 7 seconds. Let's see, did it any help or it's 7.2. So now this will be my sequential execution. Initially it will be executing this 10 cards and then executing this cards. Okay. So this is the difference. So using thread it took 7 seconds for me to calculate this, and using my normal approach it took me 17 seconds around. Okay. So using threading now you can improve the performance of your code that simultaneously can execute some independent part of methods. Okay, so this is your threading library. Any queries?
The only thing difference between the normal definition is it is much faster, that's why.
Exactly. So when I say threads, I am executing in a concurrent way, so my execution will be fast. But it's this is the thing you have to make sure that, because currently whatever architectures we are getting, the powerful servers, right? So whenever I write a code using a thread, I'm making it more complex. So I need to make sure that I'm not accessing my global resource. I need to make sure I am writing this complex code. Okay. So if your server is powerful enough to handle the data which you are consuming, then no one will suggest go for threading. Okay. But if there is some sort of lags, because ultimately we have few things. Let's say the one purpose is user should not see the lag in between. Let's say you can run something in the background so that user will feel that okay, it's working seamlessly, but in the background it will do processing. Okay. So for that processing, we have multiple things like queues architecture, uh, stacks, queues, all these things are there. So it will execute things in the background. So if you have powerful server, then you can do all this coding without use of threading also. But if you have limited resources and you want to use execution concurrently, then that we can use threading. So again, the decision will be whether you want to induce this complexity or you want to take power of this architectures. Maybe you can use clouds, which will be cheaper but efficient also. Okay.
It's widely used.
Now it's mainly in your networking domain, and the reason is you will get a limited amount of memory there. But when we say web applications and all these things, we have queuing services that can be used for your background processes instead of inducing threading. So we can use threads for your web architecture also. If you see your database accesses, right? So your database accesses can be in the background. Whenever you are, let's say, whenever you are sending a mail, you send a mail and ultimately it's a background process to be triggered, right? So let's say you are writing it in a sequential manner, then you will user will click on send mail. It will be showing that progress bar, okay, we are still sending, and after let's say 2 to 3 seconds it will send it. Okay. So what you can do is run your email execution in the background. You click next. User can do all this activity. Let's say after 2 seconds, it will drop the message that okay, mail is sent successfully, something like this. Okay, so all such activities can be done in the background. Okay, keep in mind threading is your concurrent execution. Okay, it's not a parallel execution. Okay, when I say parallel, that means I will have multiple system. Okay, and I will be executing the code in one of the system parallelly. So let's say one system is taking care of a same function. I will execute the same function on another system also. Okay, so I will have a group of multiple systems. That is my parallel execution. So that is not your threading. Okay, what is threading? That means you have a single CPU but multiple cores in the CPU. Okay, so now you are using the power of your cores. That one core will execute one function, at the same time second core will work on the second function. Okay, so this is the difference between your concurrent execution and your parallel execution. So when we are writing a threading, we are always doing concurrent execution. We are not doing a parallel execution. Okay. All right. So next thing we will start is your decorators. Okay. Again, completely independent topic. So when we discuss functions, so we passed various values, right? Num1, num2. We passed it using various method, that is star args, star kwargs, and all these things, right? But still we are passing the variables, right? So what is decorators? So using decorators, I can pass a function as a input. Okay, so that is the concept. So what is the use case of a decorator? So decorators are generally used to write a wrapper function. Okay, so decorators mainly used to provide a scalability or code. Let's say you have written one part of code which is working perfectly fine. Now there is a change requirement and you have to do some modification in that same code. Okay, now one way is modify the existing working code and write a new logic in that. Okay, there are chances that you will break the existing code too. Okay, so what you can do, you can write a wrapper function on top of that. Okay, so you have your original function. Okay, your wrapper will sit on top of it. So before actually if someone gives a call to actual function, before actually executing this function, this wrapper will make sure a particular new function is executed. Now this new function will be your new logic. Okay, so if you want, you can reuse your actual function inside your new logic. So let's say if you want to change the way we pass the input to this particular function, and then that you can do in your new logic. Okay, so the wrapper will be it's kind of a middleman. So the responsibility of this middleman is someone is giving call to this actual function. That function call needs to be redirected to this new function. Okay, that will be the sole purpose, and this wrapper is your decorator. Okay, so let's take a very example to understand this all this function call. So I have one function called print site. Okay, so function, let's say, okay, whatever is passed to this function is returning the same value. Okay, so if I give a call to this, let's say print site new. Okay, it will print me google.com. Nothing new here, right? So now what I want, same function should print me welcome to google.com. Okay, now this should remain the same. I don't want to change anything here. Okay, but the same function call, same structure should give me welcome to google.com. Okay, so how I can do this? I can write a wrapper function around it. Okay, so how to write a decorator? So we have seen static method and a class method decorators, right? How we write it? At the rate, right? Now I can specify anything here. So at the rate is mandatory. This is user defined name you are writing. Okay, so how it works? Whenever someone gives a call, so you have to make sure that you are writing just one line above your function. Okay, so if someone gives a call to print site name, okay, it will go your function call here, but before this function called there is a decorator, right? So your decorator should have an implementation. So it's a decorator is nothing but a definition. Okay, so what this decorator will do, it will take a function as an argument. Okay, so the input to this decorator defaultly will be this function, and the output of decorator will be new function. Okay, so you have to define this decorator. I'm taking something called func. Okay, so the print site name function which we are writing now will be passed as an input. So far we have seen I can pass variables, but using decorator now I can pass entire function as an input. Okay, the output will be a new function. Okay, so far how it is working, I'm giving a function call. It will go here, it will check, okay, before this function call there is a decorator call, so it will go up. Now what is the use of decorator? It will take a function as an argument and it will return some another function. Okay, so it's like a middleman. So it's taking this actual function, passing it as an argument, and it should return a new function. Now I need to implement this inner function, which will be my new logic. Okay, so okay, so in short, someone gives a call to this print site name. Instead of that, now ultimately inner function will get called. Okay, now for a decorator, it will automatically get all the arguments which you are passing for this particular function. Okay, so whatever argument is getting passed here will be automatically available here. Okay, so I need to append something, right? So return plus, and here can I give this print site function name call? Okay, so I have appended the value, and this inner function is passed as what? Fun.
I think it should be function.
Which one?
Um, yeah, second definition. Instead definition. Instead of inner function, it should be function.
No, no. So what is in this func? So this func is a underlying method which is existing. What is inner func is the new logic which you are writing, and your decorator is just a connector. Okay, so you have a method. This is your new logic. Okay, you have old logic, and your decorator is a connector in between them. Okay, this is my return. This is inner func. Now this is my function call. Okay,
that itself is a function call.
Exactly.
It's not just an object.
It's not an object. It's a function call. In case of decorators. Okay, so now I can see the I haven't modified the original method, but still I appended the output. Okay, so let's go through the function calls again. So ultimately I'm giving a call to print site name. Okay, so it will pass program control here first. It will check, but there is a decorator. That means it will go up.
Decorator always returns a function.
Exactly. So it will take a function as an argument and it will always return a function. It's like a mediator between. Okay. So function as an argument. So whatever underlying function is, it will be passed as an argument. Okay. And it will return a new function. So whenever I'm writing this inner func, this is my another function call. So when it goes to the decorator, it cannot execute these two statements unless and until obviously there is a function call. Okay, so return inner func, that means this is a function call. Okay, it will go here, it will calculate these two things, that is welcome to, okay, and function call. So when I give call to this function, it will go here and return site name, right? So that means I will get google.com here, append welcome to plus google.com, and there is a return where it will return
To the site name.
okay. So this is a return from my caller. Who is the caller for this? This, right?
This inner func is there. The argument is a site name.
Uh-huh.
We can change the site name.
Yeah. Ultimately, you will get a parameter. Okay. So this can be anything. It's just the parameter is available. You can accept it anyway. So here if you are writing 5 parameters, accept it directly as star args, that is also fine. And the reason that is the way you will do it, so it's not that I'll be writing only one decorator per function. I can write multiple decorator. I can write multiple functions, only one decorator, a generic decorator. That is also possible. Okay. So call wise, so when I write welcome to and give a func, it will return this google.com, and this is a return statement, right? Where it will return, it will always return to its caller. Who is the caller for this is here, right? Now there is a return statement. Now where it will return, this is my final return call now. Okay, it will go here. Okay, understood? So from here it went to the decorator. From decorator it went to this check inner function. From inner function, okay, go to inner function. From this inner func, there is a function called to this original func. So from that go here, then get the result and return. Where it will return the result, it will return the result here. So I'll get google.com here. Google.com and welcome to. Append these two things, and then again there is a return statement. Where it will return, so it will return to its caller. Now this is my final return statement. Okay. So take any example, the structure will remain the same. So the only thing will change is this function and this function. Okay. So let's take example of your typecasting. So let's say you have a function called concat. Okay. Pass two values to this function and it will concat or do addition for you. Let's say val1 and val2. Okay. So what it returns is return val1 plus val2. Okay. So if I say while giving the call, if I pass concat of 10 comma 10, I'll get answer as 20. If I say print concat of, let's say hi comma python, I'll get hi python. But this function call will fail if I pass this, right? I need to handle it, but I don't want to modify this function. How I can write? I can write a decorator. Let's define any name. So I need to write definition deco. I will pass something called function. I need to return the inner function. I'll get all these parameters. So here I'm getting val1 comma val2. What logic I need to write? I'll check if type of val1 is equal to type of val2. If type is same, then I don't have to do any changes. I will just say return, make a function and pass in a normal way. Okay. Else, so now what I'll do, I'll say return function call of stro val1 stro. Okay. In short, if the type is not same, then I'm saying typecast it to the string and then pass it to the function. It's just I'm just changing the way I'm defining the passing the input to the same function, right? So yes, I can write the same logic here also. But if I wanted to make sure that my old function is not touched, okay, I don't want to get into that complexity. So what I can do, I can just change the way I'm passing the input, and I can take it advantage of existing function also. Okay. So this is your concept of decorator. So structure will remain the same, be it any decorator. The things which will change is what the code which you're writing here and the code which you're writing here. That's it. But the way you define a decorator will always remain the same. Okay. So this is the concept of your decorators in Python. I guess we can finish it one more session only. So that is your socket and your database access. So everybody is aware of basics of databases. Yeah, basic, that is create query, select query. Yeah. Pawan? No? Vinay? No? Aja? Yes? Okay, sure? Heard about it. Alright. Okay. So give it a try. If you get chance, just go through the basics of concept. That what is select query, what is create table query. Okay. I'll explain it, but it's kind of a very vast topic. Okay, so I can try to give you background, but I cannot give you the full background. Okay? So just try to go through it, okay, and then we'll see how you can access database from Python process. Okay. Okay. Yeah, socket and database. So socket, I'll take care of it. Socket. Socket in this sense. Socket in this sense, whenever you are creating a client server architecture, right? So if you want to create a communication between application and the client, which is hosted on a server, then it's generally done using the socket program. Okay. So we're seeing, so whenever you make a web request or any particular get request, so we have seen that at the end we are just typing google.com. In the backend, it is making a get request to the Google server, fetching the data. If you go one level down, it is actually creating a socket with the server. It will send the data, close the socket. Let's say you click on any link, you are making a new get request. At that time, you are creating another socket, send the data, get the data, close the socket. You are sending an email, you are opening the socket, send the email. Once the email is sent, close the socket. So all these things are happening in the Python. Okay. So we'll see how we can create a socket and the steps to create it. Okay. So when you say socket also, it's a kind of set of standard processes to be followed. So we'll discuss these concepts. Okay. Sure. So we are about to finish Python. So what is your comfort level in Python? What's your comfort level in Python? We are about to finish it. So now if you think from the concept and the syntax point of view, we have almost finished every concept. Everything else remaining is kind of extra thing. It's easy. Alright, Vinay?
Last things I have to. Yeah, after classes and the network.
Right. Adra? What is the comfort level in Python? So practicing at home or not? Sure?
In Python, data sets are different equations. Different. I think that C data sets using C separate topic.
See, so if you see in C, we have all the data structures which we have, right? All the data structures